All right, let's look at a couple from worksheet 4. Again, there's nothing new this week. You just have another practice worksheet, worksheet 5 is a review worksheet. Test is Friday, so we're reviewing until then. If you're in school, one of those days is a counselor day. Another one of those days is talk about next course selection day. And so we kind of spread it out. Nothing new, just more practice, practice, practice. And so I wanted to post a video with number 9 and number 10 from worksheet 4. So write an equation for the graph given below. When writing equations, I still want to be thinking A, B, C, D, and figuring out what those are, and then kind of going from there. It didn't specify whether to write a sine or a cosine, and I can do either for this one. So I kind of need to decide ahead of time which one I want to do. If I'm thinking cosine starts at a max, so I could start there. That could be my start if I want to think about a cosine. So I'll do cosine first, and maybe I'll come back and do a sine later. So if this is a cosine, let's see. It might be good to start from the bottom up again, maybe. The midline is D, that's down 1. The starting point has been moved over right pi. And again, that can be changed. That could be left 3 pi, depending on what you want to say the starting point is. B has to do with the period. I don't see where it reaches a max over here, but I do see the other max over here. So from max to max, that's the period. And from negative 3 pi to pi, that would be 4 pi. So the period's 4 pi. That means 4 pi equals 2 pi over b. So move things around, and b is 1/2. And then amplitude would be 2. So y equals 2 cosine 1/2. Just want to go right pi, that's x minus pi, down 1 minus 1. So there's one way to write that equation. Now, if I'm thinking it's a sine wave, which maybe I should have thought, because that matches a little better. If I start a sine wave right there, that would be the start of a sine wave. A would still be 2. B, well, the period is still 4 pi, although you're starting over right here, but that period is 4 pi, so B is 1/2. C is 0 or none because we didn't have a phase shift, and D is still down 1. So y equals, and then I just plug in A, B, C, D. 2 sine 1/2 x minus 0, or just x, and then minus 1. So that's 2 of the infinitely many ways to give an equation for number 9. If you wanted to get creative, you could say the graph started here and use a negative sine wave. Or you could say it started here and use the negative cosine wave. So there's 4 different ways to go, but there's more than that, because you could start it here, or here, or here, or back over here. So tons of answers. Probably the sine answer is the best, even though I did cosine first. But either one of those are okay. Number 10, same type thing. Write an equation for the graph given below. Well, that one looks like a sine wave, so I'm gonna approach that as a sine wave. So again, A, B, C, D. The midline hasn't been moved; it's at 0. We have not gone up or down at all, so D is 0. We're gonna start right there, so there is no phase shift, no left-right shift. The period is 2. And the period is 2 pi over b. So if we move things around, that means b would be pi, and the amplitude is 3. So put all that together, and y equals 3 sine of pi x. That's it, because there's no phase shift, no vertical shift. Again, you don't have to do it there. You could say it's a cosine wave and starts right there. I'll just do that kind of on the fly because the amplitude is still 3. The phase shift is 0.5, so pi times x minus 0.5, and so there's my cosine wave. But both of those produce the same wave. It's just one using a cosine and the other using a sine. And again, you can always pick either one unless it specifies. So the assignment for the rest of this week is worksheet 5. Worksheet 5 is really long, but you have Tuesday, Wednesday, Thursday to work on it. So plenty of time to work on it. Answers are posted. I'll post more videos as the week goes on of me working some of it.